Wait. Let me do this real quick. I forgot to start recording. Everybody who's home, potentially sick or quote unquote sick, there's some announcements. You probably want the practice test from me. You should probably email me, but we'll see if you do that. Yeah, only have to go through 5-4. Okay, so if you're home, let me do some Khan Academy. Look at this stuff. Okay. If you've never seen Khan Academy, you have no idea. Khan Academy, it's just hands. Can everybody please do this for me? So I'll. That was neat. That was. Whatever it was, that's fine. That was hilarious.
You guys look like a quadratic spreadsheet. I wasn't here. Do you possibly
Oh
have
my
a
god.
copy?
Quadratic
I don't know what you guys
worksheet. Did I bring any with me? I most likely didn't bring any with me because that's.
Do you have it posted online? Or no?
No, I mean you can always email me.
Oh,
I always forget
do
to
you
put
have,
shit
is
in
there
Canvas.
also like a key for it or no?
I mean, we did it together in class.
Oh.
Yeah.
How was that?
Sorry. Does everybody understand what I'm asking to do up here? Obviously, if you've missed some lectures and you have no idea what synthetic division is, you might want to just sit there and stare at a wall. Or ask somebody next to you, what the hell does that mean? Yeah.
Is it 1 times 1 divided? Is it 1 times -5 and you subtract?
Wait. Do me a favor. Erase these. Put a line here. Now put the 1 below the line. 1 times 1 is 1. Add.
Oh,
Yep. Okay. You just have to do a few to get it in your head.
thanks.
Just to make sure everybody's got the first step going right. Right, the whole idea of synthetic division is to not even write all the extra bullshit in the first place. Just focus on the numbers. Don't tell me what you got, but is anyone getting something that's neat to see? Okay, it's a very specific result. Not all the numbers, just one of the numbers. So somebody help me out. How does this work again? I forgot.
1 times 1.
Bring the 1 down. Is that what you said? Okay. 1 times 1 is,
1.
holy shit.
-5 times 1.
And then add these together and multiply and add, right? Multiply, add, multiply, add. Now, can somebody tell me, there's several answers I'll accept. What does that 0 mean? Okay, it's the remainder. That's the first level answer I'll accept. It's just straight up, it's the remainder, Jeff. What does it being 0 tell me?
That is done with division.
That we just factored the numerator, yes? We factored the numerator. What goes into the numerator, the polynomial? What's a factor of it? What's a factor of this? What's a factor of this?
6.
No. 6 can't be a factor of this. There's no GCF. What went into it evenly? What went into this evenly? Beautiful. So does 7 go into 14 evenly?
Yes.
So is 7 a factor of 14?
Yes.
Does 5 go into 40 evenly?
Yes.
So is 5 a factor of 40?
Yes.
Does x minus 1 go into this evenly?
Yes.
So what would you say about this? That is a factor of this. Yes? Can you write this in more factored form? It's not finished yet, but so I've got this business. And we know it equals this times what?
X to the third?
Yes. It was 4th power. I divide it by roughly x. I should get x cubed. So that's 1x cubed. Somebody else tell me the next thing. X squared?
Minus 9x plus 36.
Okay. That's the beauty of synthetic division. It realizes all that really matters is the coefficients. As long as the stuff I'm working with are already in descending order, everything falls into place. So freaking nice. Stupid. If I have a remainder of 0, that means we have actually factored something, and I desperately want somebody out there, even if you hate math, it's kind of cool. There's no, look at this. Could you factor this before we got into this stuff? There's no way in hell. It's not a grouping problem. It's 5 terms. What the shit? There's no way we could have done it. Did we just factor it? Totally. So even if you're like, I don't even know what the shit that's for, on some level you should be like, look at this go. We did something we couldn't have done before. It made it. Look at us. Good. We made this shit up as humans, so we should be able to do this. Does anyone see if I could continue factoring? Let me write that up on the next picture. Could I keep going? Get out of here, strawberries. So far we got this business. So here's what you ask yourself. Do I need to do synthetic again? Or could I just straight up factor it? So again, when do you use synthetic division? Well, one really important use of it is if I want to factor something and I have no way to do it. Synthetic helps. Do we want to factor this? Yes, based on what I just said. Do I need synthetic's help to factor this? No, so then don't use it. Next thing we're going to talk about after this problem is, what would we do if I couldn't factor this? Then we'd have to use synthetic, and then you're like, how the shit do I get a number to divide by? And we sort of got into that yesterday. How do I factor this?
Grouping.
Yes, I can group. So out of this comes x squared, what's left?
It's x minus 4.
And out of this comes, yep, and what's left?
X minus
Good. And then I get x minus 1. This comes out. And I'm left with this. And then I can finally do what?
1. X minus 9, x plus 3, x minus 3.
Because that's easy. That's just the difference of squares, right? So can somebody tell me all of the roots?
1, 4, 3.
Yeah, those are only x values of the roots. So the x-intercepts would be 1, 0, 4, 0, 3, 0, 2, 0. Is everybody roughly with me? Roughly? Sort of? Okay, maybe. So my roots, or my zeros, are, or my intercepts, x-intercepts, are 1, 0, 4, 0,
3 0,
3, 0.
negative 3 0.
And of course the multiplicity of each, it's a little boring for this one. What's the multiplicity of each one? 1. So what's it going to do at each one? When the graph approaches the intercept, it's going to go through. It's not going to bounce. It's going to go through. So it goes through every single one of those. So it's going to end up looking like maybe. So let's kind of analyze this a little bit more. So we got this. It's going to go through all. Look back at the original function. What was the end behavior?
X to the 4.
So what's it going to look like at the ends? What's it going to do?
It's going to go up.
Yeah, go. Okay. So if I wanted to graph this thing, I've got intercepts at 1, 3, 4, and negative 3. What's the y-intercept of this thing?
Negative 36.
Yes, negative 36. Because when it's in that form, if I make x 0, the only thing left is negative 36. So the y-intercept is 0, negative 36. But can anyone tell me, are there any points? There's 2 points we should probably plug in because 2 of the intercepts are really close, so it probably doesn't get that far away. But what are 2 good inputs to help me graph this thing?
-1.
Yeah, either -1 or -2, so let's do -1, and then there's one that's just obvious. 2. I want to know, so I want this to make sense. If I have 2 x-intercepts, I know it's kind of like, it might go through both. In fact, we know it goes through. Then I'm curious how high or how low. I want to know what it does. How high or low does it get? So I don't have to guess. In calculus, I think this came up earlier, you'll actually calculate the exact maximum. We're not in calculus yet. So we can't do that shit, so we do the best we can. So if I plug in, what'd you say again? I'm sorry.
-1.
-1? Oh God. Well, here, watch. If I plug a -1 in, let's see if you guys are cool with this. If I plug a -1 in, what do I get here?
-2.
-2?
-5.
-5?
-4.
-4?
2.
2. 3 negatives, so the answer is going to be negative. And then 80, I believe. Is everybody with me so far? So f of -1 is -80. And f, let's do f of 2 now. If I plug a 2 in here, I get
1.
1. 2 minus 4 is,
-2.
2 minus 3 is,
-4.
2 plus 3 is much nicer. 2 negatives make it positive, so f of 2 is 10. All right, let me stop for a minute. Let me stop. This is basically everything we've already done. I just want to show you, I could start with something completely not factored, so the first part of the problem is factor the damn thing. Then you can see all the multiplicities of all the x-intercepts, the behavior. What I normally do is, and I'll say I will do this, I'll tell you what to find the value for, but you should see how you could kind of pick it yourself if you had to. What kind of scale do I want to use on the y-axis, do you think? What's the farthest output I need to get to?
36, well,
80.
10.
Let's go better. Let's go 20s. 20, 40, 60, 80. Especially because I didn't really give myself much room here. Okay, so let's see. We got a y-intercept, 0, negative 36. We got a point at -1, negative 80. And we got a point 2, 10. Okay. So it doesn't really get very far. So it could have gone like this, yes, but now we know it goes like, whee, just barely jumps out, little flying fish. Ha ha! Shit. So what gets me started? I've got all my anchor points. These are just points we plot. Let that be nice. I'm just plotting points. The intercepts, the y-intercept, the outputs of specific points. What gets me started? And behavior. So I know I'm supposed to be coming down from this side. So I start down. Thank God I do, because what do I do at every intercept? What do we figure out?
You go through them.
Go through. It's good I go through, because then I have to be over there, yes? So if you're like this and you're like, oh, wait a minute, then something went wrong. And then you can stop and check. So I go through, come back over this way, go through, come up, go through, and then I could plug something in here, but there's so little room, it really doesn't have much room to go that deep, so I'm not going to worry about it. I'm not going to plug 3.5 in. So let's see, this tells me to start here. Do you see that? This tells me to start here. I'm going to go through, and then I can hit the y-intercept.
There's the point for negative.
Oh, down here, sorry. I've got to make these bigger for myself. I've got to hit this, and then the y-intercept, and then I come through here, hit this point, then through here, and then at some I could put 3.5 in, but there's so little room, it's almost definitely not going to be something major. Do I meet up with my end behavior on this side?
Yeah.
Yes. Okay. That's why it's good to do this in different colors so you don't lose a point. It's all blue, though. It gets mischieved together. How you guys feeling? So don't look at it like a lot of stuff to keep in head. No, it's a lot of checks and balances. I got a y-intercept, I know I have to get there. I got end behavior, I know I've got to end up doing that. So if I don't, I know I made a mistake. Okay, you all look very appropriately excited. Okay. So here, let me see. Oh, I got so little time. I made a good decision to not try to do 5 today. Good Lord. So here, let's do one more example, and then I'll let you guys out of here. Yeah. Okay. Let's do that. Yes. Okay. Ha 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 ha. I would normally make you do this on your own, but we have 5 minutes. Don't say anything. Consider the end behavior. Don't say anything. If you're sitting here like, how the shit would I tell? Why was the other one easy? Because I could see the highest power. It wasn't factored yet. I've given this to you already factored, which is good. You're like, thank the gods. But what the shit is the highest power? So now tell me, what would the highest power be if this was unfactored multiplied? It would be 5th power. Does everybody see that? He would give me a squared times, he's a freaking x. So x squared, x to the 4th, x to the 5th. You do not have to multiply that shit out, dear God. No matter how much I say that, somebody's going to. And then they're like, why'd you make the test so long? I didn't. So end behavior is like x to the 5th, so what does that look like? I just love to watch you guys do that. I'm sorry, okay. So it's normal, it's not flipped, right, because it's not negative? Can somebody right now tell me, well, okay, let's do this. Let's get the y-intercept out of the way. What would the y-intercept be?
0, 0,
0, comma,
0.
hell no.
Oh, whoops.
36.
Yeah, it would be, if you make all the x's 0, yes? You just have numbers. You have 9 times 1 times negative 4 is negative 36. Do it again? 12? What about 12? What? Sorry? What's happening? All right, so if I make x 0, what number is that?
9.
9. Times 1, which is 9. Times
Negative 4.
9 times negative 4 is? Good, okay. Stay with me now. We got time. Look at how much time we got. We have so much time. What are my x-intercepts, or roots, or zeros, or whatever other word? Yeah, negative 3, 0. 1, 0. 4, 0. What's the multiplicity of this one?
2.
Because it shows up twice. This one? Holy shit. This one? 1. And all that really matters is even, even, odd. What's it do if it's even like this one?
Bounce.
Yeah, bounces. So this one bounces. And this one goes through. Okay. So I've got my x-intercepts. Let's plot those. Negative 3, 0. 1, 0. You always want to go one more. Dadgummit. 4, 0. Now I got to worry about my y scale. And again, what points do you think I should plug in?
2.
2, and I'll do negative 2. How's that sound? So I'm going to do this a little bit quickly. 2 plus 3, 5 squared is 20, is yeah, 25. 2 minus 1 is 1. 2 minus 4, negative 2. So negative 50, it seems like. I might have done that too quickly. Negative 2 would be 1 times 9 times negative 6, negative 54. Oh my god, I probably did that too fast. It's all hope. Yeah, it should be fine. So I want to make my scale kind of like go up to 54, so I'm going to make a scale by, what you got, Jeff? Joe, we'll do 10s. 10, 20, 30, 40, 50, 55. 10, 20, 30, 40, 50. So my y-intercept is 0, negative 36. Negative 36 is right there. F of 2 is negative 50, and f of negative 2 is negative 54.
You missed your scale, but
What'd I do? 10,
went
20,
from
30, 40,
10s to
50.
5s.
Oh, neato. I always love when they do that kind of shit. And then negative 2, negative 54. Okay. So this tells me where to start. And I'm only gonna go through at 4. I'm gonna bounce at the other two. So if I start down here and I bounce, I get down to here, go through my y-intercept, bounce, thankfully, so I can go through this point, and then the last point I go through. And then I match up with my end behavior, so I feel pretty good.
The only time you'll bounce at the y-intercept is if it's 0,
An
0.
even multiplicity. Yeah. These both had even multiplicities, so I bounced at both.
Can a
Because what do they
y-
act like? They act like parabolas.
Can a y-intercept have even multiplicity?
No, because then it wouldn't be a function, because it would go back on itself and not pass the vertical line test.
Okay.
Yeah. All right, guys. Well, have a good weekend.
Have a good Christmas.
Take care.